in looking at question 2, it asks use algebraic methods to decide whether these relations are functions. So I just think you need to be clear in your mind what they mean by an algebraic method. And so if we just look at the definition, we need the algebra that links the x and the y values. And so for an x value, we can only have one y value for it to be a function. So for me, the algebraic test is really supported if you are able to picture in your mind the graph. So for me, when I see y equals x squared take 9, I know because there's a square on the x that we're going to have a quadratic function, which is the shape of a parabola. And if the parabola is opening upwards or downwards, like every x value will only have one y value. So part A is a function. So being able to picture the graph from the algebra, I understand there's only one value. For each value of x, there's only one value of y. And so I guess if you plug a value in for x, you can see, I hope, that no matter whether it's a positive value of x, 1 squared minus 9 is negative 8, or a negative value of x, minus 2 squared is 4 minus 9, all right, that there's only one value of y. In part B, I recognise that as a linear equation, and so, again, very roughly, if I have the equation y equals minus x plus 9, so when x equals 0, y equals 9, it's going to have a y-intercept of positive 9, but with the slope of negative 1, it's going to have a negative slope, but it's a single line. There's one value. For each value of x, there's only one value of 9. On the other hand, when I look at the algebra, I look at the equation for C, I recognise that as a circle equation. It's a circle whose centre is 0, 0, with a radius of square root of 9, radius of 3. So if this here is 3, all the way around. So from the algebra, I can picture the relation is a circle, and I know that there are there is a value. If I can pick a value of x inside the circle, there will be two values of y, so that is not a function. This one is a relation only.